This is a problem on pump. This one is used. This one is taken from Amazon.com. You can go to the link and get all the information on this pump. All of this data you see here, they're all gathered from this website. So this is a submersible deep well pump. Typically, they are installed up to 1,000 feet below the ground to get good quality water. This pump says for the maximum power, it produces maximum power at 11.5 gallon per minute, and it develops 103 feet of head of water. And then first question is asking is calculate the pressure in psi. So develop the pressure head of water, 103 feet of water, and then convert that to in psi. So we know that P equal to gamma H. This is the one of the takeaway equation that I want you guys to take from this class. So 62.4 pound per feet cube. So if you fill 1 feet cube box with water, it's gonna weigh 62.4 pounds, and then it creates 130 feet of water. So if you cancel this feet and feet cube, you'll have feet is square. So I want this in psi, so I want to cancel that feet in the denominator. So in the numerator, I'll multiply by feet and divide by 12 inch. So I'm not just converting the unit, not changing anything. So if you calculate that, I found 44.6 psi. Next question, peak horsepower. It says it produced peak horsepower at 11.5 gallon of flow. So that peak or maximum horsepower is, we can write this equation. If pressure is in psi and flow is in gallon per minute, then divide by 1714, that will give us the value in horsepower. So we calculated 44.6 psi pressure times the flow rate 11.5 gallon per minute, then divide by 1714. I have calculated that about 3 horsepower, 0.3 horsepower. Now the horsepower loss, then this is a half horsepower pump, so 0.5 horsepower minus the delivery, which is 0.3, so the loss will be 0.2 horsepower. The primary loss of this system is because of the 1,000 feet pipe that this thing is pumping the water from. So it's installed, we don't know, probably around 700-800 feet. So the flow is coming this way, the pipe wall has friction with the fluid, so the primary loss is fluid friction. You have to be specify what you're talking about. It is fluid friction, that is the loss. Everything else is kind of negligible in this particular case. Calculate the efficiency. So we know that efficiency is the overall efficiency is the power output divided by power input. So we got our output 0.3, input was 0.5, so about 60%. Assume the volumetric efficiency is 90%. Calculate the flow rate if it produces maximum actual flow at 20 gallon per minute. So volumetric efficiency for a pump is what it actually develops and then what it should theoretically develop or produce. So 0.9 is equal to the actual flow, 29 gallon per minute, divided by the theoretical. So I calculated the theoretical flows to be 22.2 gallon per minute. And then it says calculate the size of the pump, basically calculate the displacement. We know that theoretical flow is Vd times N. If we divide by 231, then this will come in inch cube. So we can do 22.2 times 231, just bringing to the left side, and then Vd times the RPM 3450. So the volumetric displacement I calculated 1.49 inch cube. Now this question is asking that it uses most of the submersible pump because it's installed all the way down to 1000 feet. It has to develop enough pressure so that it can overcome the frictional losses of the fluid in the pipe wall. So it uses multiple stages of impeller to create that pressure, high pressure. Now it says that the flow rate that you calculated before, does it develop by one impeller or all four impeller? So the answer would be the one impeller develop that flow, create some pressure, and then transfer to this impeller, add this impeller, add some pressure, the same flow, and then goes this one, and then goes this one.